All right, good morning. This is the second lesson in our series of lessons on statistics. And what I want to do real quickly, I want to kind of review and tie up the previous lesson where we talked about measures of central tendency. Measures of central tendency. And basically what we discussed, and you don't need to copy this down, you should already have this in your notes. Measures of central tendency, the three that we discussed, are mean, median, and our mode. All right? Now, a review of all three. The mean is the average of a data set. How do you get the average of a data set? What you do is you sum all the individual numbers in a data set, and you divide that by, again, n, the total number in your data set. And that's going to give your average. And again, for our purposes in here, you're going to round that to the nearest tenth. All right, to the nearest tenth. Now, another measurement of central tendency, i.e. a central location of a data set, is the median. All right, the median. And the median is the middle value of an ordered data set. Now, remember, to get your median, as we discussed in the previous lesson, you have to order your data set from smallest to largest. And the median is the middle value. Now, it's the middle value. It's the middle value, remember, if your data set is an odd number. And we talked about the simple data set 1, 2, 3, 4, 5. There's 5 numbers in that data set. Your median is 3. But if it's an even number data set, it's the average of the two middle numbers. All right? Average of the two middle numbers. And the example that, simple example that I'll use is the data set 1, 2, 3, 4, 5, 6. You have 6 numbers in your data set. Your two middle numbers are the numbers 3 and 4. So you take the average of your two middle numbers. Your median would be, for the data set 1, 2, 3, 4, 5, 6, would be 3.5. Okay? So if your data set is even, you're going to take the average of the two middle numbers. All right? And then the last one that we, measures of central tendency that we're going to review, pardon me, I'm trying to talk 90 miles an hour, that we're trying to review is the mode. And the mode is the number or the data value that appears most often in a data set. Remember, you could have 0 modes. You could have, no mode. Let me rephrase it. You could have no mode if none of the data values are repeated at all. Then you could have one mode. All right, that would be a case where you have a data set where you have one number that is repeated. Then you can have multiple modes, 2, 3, 4, 5. But those numbers all need to appear the same amount. If a number is repeated, that doesn't make it a mode. Remember, the number that appears most often is the mode. The number that appears most often. All right, so that's a quick review of our previous lesson, and you should have had a classwork assignment on that you did yesterday. And today's lesson, we're going to switch gears, and we're going to talk about another set of measurements. The previous lesson was measures of central tendency. Well, what we're going to talk about now, and these notes you do copy and put in your notebook, we're going to talk about measures of central variation. All right? Measures of central variation. All right, so variation means we're going to be talking about how data sets, what is the variance between a data set? How does a data set vary? Okay, now some of these topics that we're going to discuss are going to be things that you've already aware of, that you've been taught in the middle school. Okay, and the first measure of variation that we're going to talk about is something called the range of a data set. The range of a data set. And to be honest with you, the range of a data set is the easiest measure of variation that we're going to deal with in here. And the range you get very easily by taking your maximum value minus your minimum value. Your maximum value minus your minimum value. Now, to get your maximum value and your minimum value, your data set needs to be ordered. All right, but to be honest with you, your data set should be ordered anyways because you're going to need your data set ordered to get your median, remember. All right, so you get your range by taking your maximum value of the data set minus your minimum value of the data set. It's the easiest of all measures of variation that you're going to deal with, okay? And I'm going to work through some examples here coming up that shows you how you calculate your range. It's the easiest of all things to calculate. The next measurement of variation that we're going to discuss, these next few topics are a little more difficult for students to understand, okay? And what we're going to first talk about is we're going to talk about what's meant by the term quartiles, all right? Quartiles. And a quartile, just like the range, I put in parentheses because I kind of should have mentioned it. The range is your kind of your spread of your data. It's the spread of your data from your maximum value minus your minimum value, okay? Well, now we're going to talk about what's meant by the term quartiles, all right, quartiles. Now, first off, the word quartile should kind of clue you into what we're going to kind of discuss. Because quartile deals with a quarter. Deal with a quarter. How many quarters make up a dollar? There are 4 quarters that make up a dollar. Therefore, a quartile is 1/4 of your data set. A quartile is 1/4 of your data set. So that means in a data set, you're going to have 4 quartiles. All right, you're going to have 4 quartiles, all right? And those quartiles are broken down into 1/4 or 25% of your data set. Now, the first thing that we're going to talk about is something called your lower quartile. All right, your lower quartile. It's also in some textbooks, it's called your first quartile, all right, your first quartile. And you'll hear me randomly discuss it throughout this lesson. I'll call it lower quartile, I'll call it first quartile. They mean the same thing. Now the notation, all right, the notation for the lower quartile is Q1 or Q sub 1. Some textbooks have it as Q sub 1. Well, your lower quartile, okay, you get by basically taking the median of the bottom 20, the bottom 50% of your data. All right, the bottom 50% of your data, okay? Now, pay attention to what I'm getting ready to write down here. I'm going to write down a simple data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? It's a simple data set. It's already arranged from smallest to largest. Okay? From smallest to largest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are a total of 10 values in our data set. Okay, a total of 10 values in our data set. Now, basically, let's talk about the median. The median is the 50th quartile. The median represents what's called the 50th, or actually, let me backtrack. The median breaks the data down into lower and upper 50%. 50% is above the median, 50% is below the median. Your median is what's called the second quartile, all right, Q2. Now, let me show you this. Everybody pay attention. And you also should have your calculators out. I'll give you a second, all right? Get your calculators out. Now, let's talk about your median first. First, we notice that I have n is equal to 10. So my data set is what? It's even. So you should know from the previous lesson, to get my median, I'm going to take my data set and I'm going to divide it in half. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the median is right here. Since it's an even number of data set, my median is the average of the two middle numbers. Well, my two middle numbers are 5 and 6. So the average of 5 and 6, hopefully you don't need a calculator for that, the average of 5 and 6 is 5.5. So my median is 5.5. But again, what your median does, it divides your data set into 50% lies below the median and 50% lies above the median. Okay? Hopefully that makes sense to everybody, that the median is the middle value. It divides the data set into the lower and upper 50% of the data set. Okay? Now, here's where the quartiles come in play. What did I say the quartiles do? They divide your data sets up into 1/4 or 25%. Okay? i.e. the word quartile. Well, here's my lower 50%. How many quartiles are in your lower 50%? There's 2 of them, because 25% plus 25% equals 50%. Your lower quartile, or again your first quartile, is basically the median of your lower 50%. Let me repeat that. Your lower or your first quartile, Q sub 1, is the median of your lower 50%. Well, let's look at this lower 50% of my data. What is the median of that lower 50%? It's this value, 3. 3 would be what we call the lower quartile. 3 is what we call the lower quartile, because it's the median of the bottom lower 50% of your data set. Okay? So remember that. Your lower quartile is the median of your lower 50%. So to get a quartile, just like to get a median, your data set has to be arranged from smallest to largest. Okay? So you better get in the habit of arranging your data set from smallest to largest. Now, Mr. Byers is going to be nice to you, because Mr. Byers is going to order your data set from the smallest to largest on your classwork and on your quizzes, tests, and exam. I will already do that for you. You're welcome. Okay? So again, the lower or first quartile is the median of the bottom 50%. Well, let's think about this. If I have a lower quartile, all right, which is the median of the lower 50%, then I probably should have what's called an upper quartile. Or it's also called the third quartile. Okay? It is in textbooks, some of them, textbooks call it the upper quartile, some of it call it the lower quartile. Or excuse me, the third quartile. Let me rephrase that. Some textbooks call this the upper quartile, and some textbooks call it the third quartile. And the notation is Q3, your third or your upper quartile. Now, hopefully you're able to go back to this data set and you're able to connect your understanding with your lower quartile is the median of your lower 50% of your data, And now you can apply that same understanding to be able to calculate your upper or third quartile. What do you think it is? I'll give you a second to think about it. The second has passed. If your lower quartile or your first quartile is the median of your lower 50%, hopefully it's not a stretch to understand that your upper or your third quartile is the median of your upper 50% of your data. All right, your upper 50% of your data. Okay? So that's how you get what's called your lower and upper quartiles. All right, your lower and your upper quartiles. All right, now we have one other measure of variation that we need to discuss, and that's something called the whoops, we got an R there, your interquartile range. All right, your interquartile range. And we're going to use the notation or the abbreviation IQR. So anytime you see the abbreviation IQR, that stands for interquartile range. Well, how do I find the interquartile range? Well, since it has the term range in it, let's go back and review, okay, what is termed range. Remember, I get the range of my set of data by doing what? The maximum value minus the minimum value. Max minus min is your range. Now my interquartile range is very similar. My interquartile range you get by taking your upper or third quartile minus your lower quartile. Okay? So, to summarize, the values that I'm going to look for you to calculate, your maximum, your minimum, real easy. Everybody should be able to calculate what's the maximum and minimum values of a data set. Your range of your data set. Well, in order to get your range of your data set, you got to take your max minus your min. Then you're going to find your first and third quartiles, knowing that your first quartile is the median of the lower 50%, your third quartile is the median of your upper 50%, and the interquartile range is the Q sub 3, minus Q sub 1. All right, now, let's get the calculators out and let's start, get some applications here. All right, so the first thing we're going to talk about is, we're going to talk about starting salaries. All right, starting salaries. And I will give you this data set. And again, I'm going to give it to you in an ordered fashion. So here's the data set. 7,300, and you need to be copying this down. $9,500, $10,450, $11,600, $12,000, $13,350, $13,400, $14,800, okay, oops, $14,800, $16,000, $16,200, got a few more, $16,900, $20,050, $26,100. Okay? So this is our data set. And again, class, I will give you your data set in an ordered fashion. Okay? And what I want you to do is, we're going to calculate the different measures of variation. All right? Now, the first thing I suggest you do is to calculate the total number in your data set, because that's going to have an effect on your upper and lower quartiles. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 numbers in my data set. Okay? 13 numbers in my data set. So now from our previous lesson, a couple days ago, everybody ought to be able to calculate the median of your data set. Since I have 13, it's the middle number. That means I'm going to have 6 numbers that are below my median, 6 numbers that are above my median. 1, 2, 3, 4, 5, 6. There's my median, 13,400. 1, 2, 3, 4, 5, 6. So my median is 13,400. I would find your median first on all of these applications. All right? Now, let's go start calculating our measures of variation. All right, my maximum value. Pretty easy to get your maximum value. It's $26,100. All right, $26,100. Your minimum value. Your minimum value is pretty easy as well. Your minimum value is $7,300. Okay? So everybody should be able to identify your max and your min. Next, find your range. Your range is real easy. It's your maximum value, 26,100 minus 7,300. Okay? So we go to our calculators. I take $26,100 and I subtract $7,300. Your range of your data set is $18,800. $18,800. That is your range. Okay? That is your range. So if you go back and look, I've already got 3 out of the 6 measures of variation. The range, the max, and the min are the easiest. Pretty easy. Okay? All right. So now I want to take my data set and I want to calculate the what? I want to calculate the upper and lower quartiles in order to get my interquartile range. Now, everybody look here. This is my lower 50% of the data. This is my upper 50% of the data. How do I know that? I know that because my median is 13,400. 50% of the data lies below the median, 50% of the data lies above the median. Okay? Now, calculate my upper and lower quartiles. Remember, the lower quartile is the median of the lower 50%. Well, let's look here. 1, 2, 3, 4, 5, 6. I have 6 numbers in my data set. 6 numbers. So from our previous lesson, the median is the average